Good evening, students. So I think only four students have joined, and I should start because it's already 4:10. So in the previous class, we have discussed about the gross command area. I hope I have made it clear also. The culturable command area, intensity of irrigation, annual irrigation intensity, net and gross zone area, net and gross irrigated area, area to be irrigated, nominal duty, nor watering, nor core depth or core period, the PALCO, crop period, base period, delta, then duty of water. Okay, and we have discussed one numerical also. Before going further, I will be telling you about the net culturable area of the India and all these. What are the present area we should be discussing? Okay, so in this, if we talk about net irrigated area, so that is 65.26 million hectare. It's capital M. If we talk about the gross irrigated area, then it is equals to 91.53 million hectare. Okay, but if we cross about our talk about our cropping intensity, then it is 145%, 145%, and the net zone area is equals to 142 million hectare. Okay, but if we talk about which area we are not irrigating nowadays, then net unirrigated area, if we talk about that, then it is equals to 103.72 million hectare. Okay, and if you see over here, we have talked about the gross irrigated area also. So if we talk about the gross unirrigated area, then it is equals to 103.72 million hectare. Oh, sorry, over here it should be 75.54 million hectare. Okay, so can anyone tell me what you have described from these data? I think you all are unmuted. Anyone please give me the answer. What you have understood by all these things? I'm waiting, students. Hello. No one is giving me the answer. Why? Okay, someone has messaged me. Let's see what's there. Irrigation area. Okay, of course, beta. It's a irrigation area, but something else also you have might describe from these data. Ki what extra it is given if we talk see in this. If we see that how much area we are sowing, so it's given 142. Okay, and if we see out of this 142 million hectare, how much we are irrigating? We are irrigating 65.26 million hectare. Okay, and how much we are not irrigating? We are not irrigating around 75.954 or million hectare area. Okay, so it, if we add these two things, then it will be approximate equal to 142 million hectare. Okay, it will come around 140 like this because in some areas, some means overall calculation of this it's somewhat disturbed, but it will be around 140 million hectare. Okay, and if we see the gross irrigated area is given 91.53. Okay, so by subtracting this gross irrigated area, we can calculate how much area is irrigated more than once. Okay, and if you see 91.53, if we subtract this from 65.26, so you will be getting around 26.26, you can say, or 26.27. An area we are irrigating means area is irrigated, this area irrigated more than once. Okay, and if we see ki how much percent of if we talk about how much percent of geographical India, uh, out of which we are taking in the total cropped area, then in percentage it is 46.9%. Okay, as you all know, our geographical area is around 128 million hectare. Okay, but how much we are sowing? We are sowing only 142 million hectare. So if we calculate this, it will be around 46.9%. Okay, so we have described, or we have concluded it that whatever we are concluded from these data are over here. Okay, कि this area is irrigated more than once, and this 46.9% is exactly the percent of GI, means geographically India, to total cropped area. Okay, now we should move further. Now over here we are having this QMEC day. Okay, so let's see what is the QMEC day. The QMEC day is actually the quantity of water flowing for one day at the rate of 1 QMEC. Okay, can anyone tell me? I have described this also. What is QMEC? I'm waiting, students. Tell me. Yeah, it's rate of flow, but what is the full form of QMAC? Measured by cubic. Yeah, what is the full form? Cubic meter area in 1 second. Of course, it's correct. It's a cubic meter per second. Okay, means how much volume we are irrigating in per second. That is the cubic. But if we talk about the cubic day, then it is the quantity E of water flowing for 1 day, and that is at the rate of what? What's the rate over here? That is the 1 cubic meter per second. Okay. Now we are having the second one. We are having the outlet duty. So the outlet duty, it is that duty at the head of water source. Means what? As I told you, what is the duty? Duty is how much this area we are irrigated it out, and the ratio of these with respect to the quantity of water applied to the crop. Okay, so the outlet duty is means whatever area we are irrigating being divided by the quantity of water, this ratio at the head of the water course is known as the wide outlet duty. Then we are having water allowance, and a water allowance, it is something designed number of cumecs of outlet capacity per 1000 and hectare of culturable command area under the outlet. Okay, since you have already discussed what is the outlet. Okay, so means at the outlet capacity we have designed such that okay, at this outlet we are getting a certain number of cubic, means cubic meter per second, and the quantity of water, or but the area over there is 1000 hectare. This is fixed. Okay. So the water allowance is the outlet capacity per 1000 hectare of cultivable command area. In short, you have to learn this also. Okay, then we are having rotational irrigation. Okay, so this rotational irrigation is usually also known as the varabandi irrigation, and it is a such a system of rotational supply of irrigation water to ensure equitable supply, right, to all farmers in a localized area of an irrigation and system. And in that we have to don't bothered about the location of the field. Okay, and one more term I have missed out, and that is rostering. That is rostering system. Okay, this rostering system is usually the process of irrigation water distribution. Irrigation water distribution. Okay, so if we talk about and further, it is also known as the regulation. Okay, and it is very necessary in a canal and system. Okay, means this rotational regulation system, or the your roadway system, it is related with the canal system, and where the demand is only on the part of the system. Okay, and water is conveyed to that part only, or when the demand is on the entire system, but the available supply is not adequate to meet that demand. Have you understood? Means I'm repeating once again. In it is usually for the canal system. Okay, where The demand is only on a part of the system, means out of the system, all the system, only one part of the system is demanding the water, and water is conveyed to that part only. Or when the demand is on the entire system, means if we see in this is the whole system, but if only the part of the system is required that irrigation, so we can and adequately supply to this part of the system. But if the demand of entire system is there, then this available water is not adequate to meet the demand. So that is known as the roastering system. Okay, in one time we will be giving the irrigation to this part, and in other time we will be supplying to this part, and then the supplying of irrigation will be at some other point, and not at a same point we can't apply to all the a part of the system. That is known as the roastering system. Only the part of one system is adequately or adequately we get the water. Okay, now moving further, we are having the soil water relationship. Okay, and if we talk about whatever the relationship between the soil, water, plants, and the atmosphere, if we say, then that whole system is known as SPAC, and that term is known as the soil plant water relationship. Okay, and if we talk about this SPAC, if we talk about this SPAC, the full form of this SPAC is also very important, because in many exam is called, this is the soil plant atmosphere continuum. And please remember this, because in many exams the full form of this SPAC has been asked. What is the soil plant atmosphere continuum? That is known as the SPAC. And if we talk about the soil plant relationship, this usually deals with those physical quantities of the soil and water that influence the your movement, retention, and the use of water by plants. And that much be considered how we are going to arrange the efficient irrigation system. Okay, and before that, if we talk about the soil water relationship, if the some questions arises in our mind, ki, okay, we have sown our crop in the field. Okay, but at what time we have to irrigate, means when to irrigate, the timing of the irrigation. And there should be some person at the, means if you are having the plants in your, or means at your home in your garden or anywhere, or to usually father or mother used to tell us that don't irrigate at afternoon. Okay, don't give water to the plants and at the afternoon. But in our childhoods we don't know why they are means not allowing to who give water to the plants at the afternoon. Okay, so this if we properly, means as we have grown up and we have to take care of all the field crops, so the first question arises in the mind is when to irrigate. Okay, then the second question means, okay, if we get the answer ki okay, at this time we have to irrigate the crop, but how much we have to irrigate? The second question, how much water to apply? Okay, and of course if we get this also, we know, okay, okay, this much water we have to give to this plant. And then the third question arises, okay, we know that time, and now we know the quantity also. Oh, but how we are going to fulfill means how, what are the methods should be there so that we can irrigate the crop means the question, third question is how to irrigate the field. This methods we have already discussed. Okay, now we have to focus about the time and quantity, but all together also I will tell you means after first I will tell you the time, the quantity, and then I will tell the questions which usually ask the methods ki how to irrigate the field. So over here we are having in some important crops. So let's see that the first thing, water requirement went of different crops means the quantity I'm discussing over here. As we know that the wheat crop usually required 450 to 650 millimeter of water in the entire life cycle. Okay, then we are having the paddy. It usually because as the paddy crop also direct sowing have been in means have arisen, and now the quantity of water is decreases in the paddy crops also. So in that 900 to 2500 millimeter of water is there. Or if we talk about the maize, the water requirement is usually 500 to 800 millimeter water. Or then we are having the sorghum, and in sorghum, it is 450 to 650 millimeter of water. Or if we talk about the sugar cane, in it is 1500 to 2500 millimeter of water. The tobacco, it is usually 400 to 600 millimeter water. Then tomato, 600 to 800, and these all crops are very important because these crops are usually he asks in the exams also. So who learn it by heart are the water requirement of these crops. Then P we are having 350 to 500 millimeter, or and in onion also it is 350 to 550 millimeter. The cabbage is 350 to 500 millimeter. So over here in this slides I have discussed about the water requirements of different crops. Now the second thing, thinking at some more crops we will be discussing. Then we will be seeing the critical stages mean in the time to irrigate also. Second, then we are having the sugar beet, that is 550 to 750. Soybean, it is 450 to 700. Then groundnut, and the groundnut and soybean is the most important oil seed which we have to discuss. So also, we should remember this, and these both the crops are kharif oil seeds also. Then we are having the cotton, 700 to 1300 millimeter. This cotton is also the kharif crop. Of sugar cane we have already discussed. Then if we talk about the millets, then and the first millet is the pearl millet. Then it is also 450 to 600 millimeter. If we talk about some fruits, the banana is there, the citrus, grapes, pineapple. These are the important fruits which we have to learn. And for banana it is 1200 to 2200 millimeter, citrus 900 to 1200 millimeter. For grapes it is 500 to 1200 millimeter, and for pineapple also, though it is around 700 to 1000 millimeter per water. And if the critical stages we see, and the critical stages is usually the life saving irrigation. Okay, means at this point if we irrigate the crops, the yield of the that crop is going to be increased. And if we don't give at this, then the failure of the uh, crop will be there. And we all know the wheat crop, the critical stage is the crown root initiation. And then we if we can apply, if we only can give only one irrigation, then we have to give at the critical crown root initiation stage. And if we can give the second, then that is this shooting and heading stage. Okay, then for paddy, we all know the panicle initiation and is the most important or the critical stage of the irrigation. Then we are having a heading and flowering stages. The first one is very important. Usually these one is asked in the exam. That's why I have mentioned one over there. Then for maize, we all know the tasseling. Tasseling is very important, and the silking also is important stage. And after that, we are having in early grain formation. But we have to focus on these in the tasseling and silking. Okay, then we are having the sorghum, and I have taken the most important crops first, because then you will be able to understand. And if we talk about the sorghum, it is the rooting stage. Then we can go for the flowering stage also. Oh, and milky and dough stage. Okay. Then in sugarcane, it is very important because this formative stage, and this question have been asked in AFO very frequently. This key, what is the critical stage for the sugarcane? The formatting stage and the tillering stage is important one, but this one is very important. Then we are having about the barley, which is the your rabi crop also. And in rice wheat cropping system, if in wheat crop we are having phalaris minor as the noxious wheat over there. So due to crop rotation, and we can go for the barley in that field. And I have discussed this also in your class. So remember all these things, because these kinds of questions are usually asked in the exam. For the barley, it also shooting and heading. Then we are having in your soybean, and as you all know, in the soybean, it is oil seed as well as the protein, means it can come in the pulses also. So your flowering and the seed formation is very important. Okay, then we are having the groundnut. So in a groundnut, this flowering is very important, because all maybe you all know कि groundnut plants usually flower inside the earth. Okay, so if whatever the flowers means if the flowers will be 100, then your peg formation or the peg penetration, you can say, is depend on the flowering. And then whatever peg penetrate, that is going to be developed in the pot. So all these things, the all these stages at which the flowering to peg and from peg to pod development is very critical for the ground nut crop. Okay, Then we are having this cotton, and in cotton and flowering and ball development means how much flower occur, and after that that flower develop into the ball, because some insects usually affect these flowers and the ball development does not occur. Okay, so or if at the time of the flowering the wilting condition occur, so at that time this flower or means itself get detached from the your this pedicle, and this
Yes, students, good evening. Due to some network problem to Richa, this one connection is disconnected. So this class will be continued in next class. Okay, we will be ready for 8 o'clock, 8 p.m. English class. Okay, sorry for inconvenience. How many people is there? Swati, Bhavya, and Nandini. Okay, you may leave now. Class will be continued in next class. Okay.